What if the ticking clock on your wall, the schedule you meticulously follow, and even the concept of days and nights are nothing more than a grand illusion? Ancient civilizations like the Mayans and Egyptians saw time not as a linear path but as a cyclical dance, repeating endlessly like the seasons. Fast forward to today, and modern science is challenging our understanding of time in ways that might make those ancients nod in agreement. From Einstein's theory of relativity to cutting-edge quantum physics, the notion that time could be an illusion is gaining traction. Imagine a reality where past, present, and future coexist, where the flow of time is nothing but a trick of the mind. In this video, we'll explore 15 strange yet compelling theories that question the very fabric of time and reality. Each one will stretch your imagination, challenge your assumptions, and leave you wondering, what if everything we think we know about time is fundamentally wrong? Get ready to dive into a journey that might just change the way you see the universe. What if time, as we understand it, isn't real? This question has puzzled thinkers for centuries, and the answers we've uncovered are as diverse as they are fascinating. Let's start with Sir Isaac Newton, who described time as an absolute universal constant, a steady, unchanging flow that ticks away independently of everything else. In Newton's view, time was like a river, always moving forward at the same pace for everyone, everywhere. This idea dominated science for centuries, painting time as an unwavering backdrop to the universe. But then came Albert Einstein, who turned this notion on its head. In his theory of relativity, Einstein revealed that time is not absolute but relative. It can stretch, slow down, or speed up depending on factors like gravity and motion. Think about it. An astronaut orbiting Earth ages slightly slower than someone on the ground. Time, in this view, is more like a flexible fabric, woven into the very structure of space itself. Einstein's discoveries challenged our understanding of time as a fixed, universal constant, opening the door to even more profound questions. Cultures around the world perceive time in vastly different ways. In some societies, time is seen as cyclical, a repeating loop of seasons and events. In others, it's linear, a straightforward march from past to future. Even on a personal level, our experience of time varies. How often have you felt like time flies when you're having fun but drags when you're bored? This subjective nature of time raises an intriguing possibility. Could time be a construct of the human mind rather than a fundamental aspect of the universe? This idea has sparked intense debate among physicists and philosophers. Some argue that time is an illusion, a byproduct of how our brains process change and events. Others suggest that it might emerge from deeper, more fundamental laws of physics that we have yet to fully understand. The more we explore the nature of time, the more we realize how little we truly know. Is it a fundamental dimension of the universe, or is it something we've created to make sense of our existence? The answer might just reshape everything we thought we knew about reality itself. What if everything that has ever happened is happening or will happen already exists all at once? This is the mind-bending idea behind the block universe theory. Picture the entire universe every moment in time as a single, unchanging four-dimensional block. Instead of time flowing like a river, the past, present, and future are all equally real, fixed in place like frames on a movie reel. Each frame represents a slice of time, but the entire reel exists simultaneously from the first frame to the last. In this model, the now is just where our consciousness happens to be in the block, giving us the illusion that time is moving forward. This theory turns our everyday understanding of time completely upside down. We're used to thinking of time as a straight line with the past behind us and the future ahead. But the block universe suggests that time isn't linear at all. Instead, it's more like a landscape where every moment is equally present. Imagine walking through a forest. You can look back at the path you've taken or forward to where you're headed, but the entire forest already exists waiting for you to explore it. In the same way, the block universe says that all of time is already there, unchanging and eternal. But this raises a profound question. If the future is just as fixed as the past, does that mean our choices are predetermined? If every moment is already part of the block, does free will even exist? Some argue that our sense of making decisions is just an illusion, a way for our brains to process the predetermined sequence of events. Others suggest that free will still operates within the block, with our choices becoming part of the structure as we experience them. It's a debate that challenges not just how we see time, but how we see ourselves. The block universe theory forces us to rethink some of our most fundamental assumptions about reality. Could it be that our perception of time as something that flows is just a trick of the mind? And if so, what does that mean for our place in the universe? Whether or not you accept this theory, it's a fascinating way to look at the nature of time and perhaps the nature of existence itself. What if time isn't just a steady, unchanging river, but something with a specific direction like an arrow? This idea, known as the arrow of time, suggests that time flows in one distinct way, from the past into the future. But why does it move this way, and could it ever flow backward? To unpack this, we need to look at the second law of thermodynamics, which tells us that in any closed system, disorder or entropy always increases. Think of it like a cup of coffee cooling down. Heat spreads out into the air until everything reaches the same temperature. That's entropy at work, and it's the reason we see time as moving forward. But here's where it gets fascinating. If the laws of physics are time-symmetric, meaning they work the same whether time moves forward or backward, why do we only experience time in one direction? Why do we remember the past but not the future? This paradox has puzzled scientists for decades. One theory suggests that the arrow of time isn't a fundamental property of the universe but an emergent phenomenon, a result of the way particles interact on a larger scale. In other words, it's not built into the fabric of reality. It's something that arises as a consequence of how things are arranged. Another intriguing angle is the role of the Big Bang. At the moment of the universe's birth, everything was in a state of extremely low entropy. As the universe expanded, entropy began to increase and the arrow of time emerged. Some scientists argue that if the universe were to contract, if it headed toward a big crunch, time might reverse. But for now, we're stuck with a universe that's expanding, entropy that's increasing, and time that's moving relentlessly forward. So, is the arrow of time an absolute rule, or is it just the way we perceive the universe's unfolding? While we may not have all the answers, exploring this concept invites us to rethink our understanding of reality itself. It's a reminder that even something as seemingly straightforward as time is filled with mysteries waiting to be unraveled. What if everything that has ever happened or ever will happen exists right now, not as memories or possibilities, but as equally real, unchanging moments? This is the core idea behind Eternalism, a fascinating perspective that reshapes how we think about time. Unlike the common view that only the present is real, Eternalism suggests that past, present, and future are all equally valid and coexist in a vast, unchanging structure. Imagine time as a book. Every page, every chapter is already written, and all of them exist simultaneously. You might be reading one page right now, but the others are no less real just because you're not currently looking at them. This idea is closely tied to the block universe theory, which visualizes the universe as a four-dimensional block where time is just another dimension, like length, width, or height. Picture spacetime as a loaf of bread, with each slice representing a single moment. In this view, the past isn't gone, and the future isn't uncertain. They're simply different slices of the same loaf. Eternalism takes this concept a step further by grounding it in philosophy. challenging our intuitive sense that the present moment is somehow more significant or real than what came before or what lies ahead. This perspective forces us to reconsider the nature of reality itself. If all moments in time are equally real, what does that mean for our understanding of existence? It suggests that the flow of time, the feeling that moments are constantly slipping from the future into the past, might be an illusion. Instead, time could be a static landscape with our conscious experience moving through it like a spotlight scanning across a stage. This raises profound questions about free will, destiny, and the nature of the human experience. Are we truly making choices, or are our actions already part of this unchanging tapestry? Eternalism also invites us to think differently about our place in the universe. If the past and future are just as real as the present, then every moment of your life, every triumph, every heartbreak, every quiet moment in between exists eternally. This can be both comforting and unsettling. On one hand, it suggests that nothing is ever truly lost. On the other hand, it challenges our sense of agency and the uniqueness of the present moment. It's a perspective that doesn't just alter how we think about time, but how we think about ourselves and our connection to the cosmos. But what if the past and future are not real in the way we think they are? Enter Presentism, a compelling yet controversial theory that suggests only the present moment truly exists. Unlike Eternalism, which treats past, present, and future as equally real, Presentism argues that the past is gone, nothing more than a memory, and the future is yet to come, existing only as a possibility. This idea feels intuitive. After all, don't we all experience time as a series of nows? Philosophically, Presentism aligns with our lived reality. It captures the immediacy of our consciousness, the way we feel anchored in the present. Think about it. Even when you recall a cherished memory or plan for tomorrow, you're doing so in the here and now. But this raises deeper questions. If the past isn't real, what does that mean for history, for cause and effect? And if the future is just a blank slate, how do we make sense of the predictability we observe in the universe? Scientifically, however, Presentism faces challenges. Einstein's theory of relativity, for instance, suggests that time isn't absolute, it's relative to the observer. This implies that what's now for one person might not be now for another, complicating the idea of a single, universal present. Additionally, phenomena like quantum entanglement hint at connections that defy our linear understanding of time, further muddying the waters for Presentism. So, is the past just a memory and the future merely a possibility? Or does time, in some form, exist beyond our immediate experience? These questions don't just challenge our understanding of reality, they invite us to rethink how we perceive the very fabric of existence. Picture a river in the dead of winter, its surface frozen solid. Beneath that icy stillness, the water continues to flow, unseen and uninterrupted. Now, imagine the universe in a similar way, a vast, frozen expanse where time itself is merely a surface illusion, while the deeper fabric of reality remains timeless. This is the essence of the timeless universe theory, a mind-bending idea that challenges everything we think we know about existence. Here, time isn't a fundamental feature of the cosmos, but something that emerges from its deeper workings, like ripples on that frozen river. At the heart of this theory lies quantum gravity, particularly frameworks like loop quantum gravity, which attempt to reconcile the laws of quantum mechanics with the fabric of spacetime. These theories suggest that at the smallest scales beyond atoms, beyond particles, time might lose its meaning altogether. Instead of a continuous flow, reality could be composed of discrete, timeless building blocks, like individual frames in a movie that only appear to move when viewed from a distance. This idea naturally leads to some startling paradoxes. If time isn't real, what does that mean for cause and effect, for our memories, for the very notion of past, present, and future? It's as if the entire universe is a single, unchanging snapshot, and our perception of time is just a trick played on us by the way we experience reality. Think of it this way. If you were to zoom out far enough, the entire history of the universe from the Big Bang to the distant future might all exist at once, like a cosmic tapestry woven from every possible moment. This challenges our everyday intuition, but also opens the door to profound questions about the nature of existence itself. Is change just an illusion? Are we, in some sense, eternal, even as we experience the fleeting nature of life? The timeless universe theory doesn't just push the boundaries of physics, it forces us to rethink our place in the cosmos. It's a reminder that reality may be far stranger than it appears, hidden beneath the surface of our everyday perceptions. And while this theory might seem abstract, it's a powerful reminder that the universe is still full of mysteries waiting to be unraveled. What if the linear flow of time we all take for granted is nothing more than a clever fabrication of the mind? Imagine this: every second, minute, and hour we experience might not be an objective feature of the universe, but rather a construct of our own consciousness. This idea, rooted in neuroscience, suggests that our perception of time as a steady, sequential march is an illusion, one crafted by the brain's intricate processing of sensory inputs. Take, for instance, experiments where researchers manipulate time perception. In one study, participants were exposed to a series of rapid visual and auditory stimuli. When the stimuli were altered, such as playing a sound slightly before or after a visual cue, the brain rewrote the sequence of events to make sense of the mismatch. This temporal binding shows how our brains stitch together sensory information to create a coherent timeline, even when the timing of events is objectively out of sync. It's as if the brain is a master storyteller, weaving a narrative of cause and effect that feels seamless but may not reflect reality. But this raises a deeper question. If time perception is so malleable, what does that say about our experience of the present moment? Philosophers and scientists alike have theorized that the now we feel is not a single, fixed point but a constructed experience. The brain gathers sensory data over milliseconds, processes it, and presents it to us as a unified snapshot. In essence, the present moment is a fleeting illusion, a mental trick designed to help us navigate the world. So, is time just a mental trick? It's a provocative thought, one that challenges our most fundamental understanding of reality. If our perception of time is a construct, what does that mean for our experience of life itself? Could it be that the past, present, and future are all happening simultaneously, but our brains filter them into a linear sequence so we can make sense of it all? As we continue to explore this fascinating theory, one thing becomes clear: time as we know it may be far more mysterious than we ever imagined. Could time be something that varies from one universe to another? This is where the multiverse theory takes us into uncharted territory. The idea that our universe is just one of countless others opens up a fascinating question. Does time work the same way across all of them, or could it be entirely different, or even non-existent in some? Imagine a universe where time flows backward, or one where it's not a straight line but a tangled web of moments. The multiverse theory suggests that time might not be a universal constant, but instead a local phenomenon unique to each universe. This means that while we experience time as a linear progression here, another universe might operate in a way that's completely alien to our understanding. And what about the possibility of multiple timelines existing simultaneously? Picture this: every decision you make spawns a new universe, creating an infinite web of parallel realities where every outcome plays out. It's a dizzying concept, but it challenges us to rethink what time really is. If time can vary so dramatically across universes, does it still hold the same meaning? Or is it just a construct shaped by the specific rules of each reality? The multiverse theory doesn't just expand our view of the cosmos, it forces us to question the very fabric of existence itself. What if time isn't something that exists independently of us, but instead a construct of our own consciousness? This idea might sound radical, but it's a theory that's been explored by both philosophers and scientists for centuries. At its core, it suggests that time isn't an objective feature of the universe, but rather a framework created by our minds to make sense of the world around us. This perspective is deeply rooted in philosophical idealism, which proposes that reality is fundamentally mental or experiential. Thinkers like George Berkeley and Immanuel Kant argued that time and space are not external entities, but tools our consciousness uses to organize experience. But how does this play out in real life? Consider the way time seems to stretch or compress depending on our state of mind. When you're deeply engrossed in an activity, hours can feel like minutes. On the other hand, a stressful or painful event might make seconds drag on endlessly. These subjective experiences hint at the possibility that time perception is deeply tied to consciousness. Scientific studies have further explored this connection by examining altered states, such as meditation, psychedelics, or even near-death experiences. In these states, people often report a sense of timelessness or the distortion of time, suggesting that our perception of it isn't fixed but malleable. So, does this mean time is just a mental construct? If consciousness shapes our experience of time, could it also be creating it? This question challenges the traditional view of time as a linear, unchanging dimension. Instead, it opens the door to the idea that time might be a dynamic, subjective phenomenon, shaped by the mind in ways we're only beginning to understand. Whether you find this theory mind-bending or credible, it certainly invites us to rethink our relationship with time and the nature of reality itself. What if everything we think we know about time is just the tip of the iceberg? To dive deeper, let's explore the mind-bending idea that time itself might emerge from the strange and unpredictable world of quantum mechanics. Unlike the steady, predictable flow of time we experience in our everyday lives, the quantum realm operates by entirely different rules. Here, particles can exist in multiple states at once, and events don't always follow the straightforward cause and effect relationships we're used to. This raises a fascinating question. Could time be a byproduct of these quantum processes? One of the key concepts here is quantum entanglement, where particles become so deeply connected that the state of one instantly influences the other, no matter how far apart they are. This phenomenon seems to defy our classical understanding of time and space. If entangled particles can communicate faster than the speed of light, it suggests that time, as we know it, might not be fundamental at all. Instead, it could emerge from these intricate quantum interactions, almost like a kind of cosmic illusion. Take, for instance, the famous Schrödinger's cat thought experiment. In this scenario, a cat inside a box is simultaneously alive and dead until someone observes it. This paradox highlights how quantum systems can exist in multiple states until a measurement forces them to choose one. But where does time fit into this? Some physicists argue that time itself might be a kind of measurement, a way to track the evolution of these quantum states. If that's true, then time might not flow uniformly but could instead emerge from the complex dance of particles and their interactions. Quantum mechanics also challenges our ideas about causality, the notion that cause must always precede effect. In the quantum world, particles can seem to know the outcome of an event before it even happens, blurring the line between past and future. This has led researchers to propose that time might not be a linear arrow, but more like a network of possibilities, with each moment connected in ways we're only beginning to understand. So, what does all this mean for our understanding of reality? If time is a quantum phenomenon, it could completely reshape how we think about the universe. Instead of a fixed, rigid framework, time might be fluid, flexible, and deeply intertwined with the fabric of existence. While this idea is still in its infancy, it opens up incredible possibilities for new discoveries, hinting that the true nature of time is far stranger and more fascinating than we ever imagined. What if the very fabric of our reality is nothing more than a cosmic projection? The holographic principle takes us down this mind-bending path, suggesting that everything we perceive, stars, galaxies, even the passage of time, might just be an illusion encoded on a vast, two-dimensional surface. Imagine the universe as a hologram where all the depth, motion, and complexity we experience are merely an elaborate trick of information. This isn't just science fiction. It's a serious theory that's reshaping how we understand the nature of reality itself. At its core, the holographic principle draws from the strange behavior of black holes. When matter falls into a black hole, it's theorized that all its information isn't lost but stored on the event horizon, a two-dimensional boundary. This idea has been extended to the entire universe, proposing that our three-dimensional world is, in fact, a projection of data stored on a distant 2D surface. Time in this framework might not be the linear, flowing river we perceive, but a lower-dimensional construct, like a shadow cast by something far more fundamental. So, what does this mean for our understanding of time? If the holographic principle holds true, the passage of time could be an emergent property, an illusion arising from how we process this lower dimensional information. Think of it like watching a movie. The film itself is a series of static frames, but when played, it creates the illusion of motion and continuity. Similarly, time might just be the way our brains interpret a deeper, timeless structure. The implications of this idea are staggering. It challenges our intuitive understanding of existence, suggesting that the very flow of time, and by extension, cause and effect, might be a kind of cosmic trick. It also opens up profound questions about free will, determinism, and the nature of consciousness. Are we truly moving through time, or are we just experiencing a pre-encoded sequence like characters in a holographic story? What's particularly fascinating is how this theory bridges the gap between quantum mechanics and general relativity, two pillars of modern physics that have long seemed incompatible. By treating space and time as emergent phenomena, the holographic principle offers a new lens to explore the universe's deepest mysteries. It invites us to rethink not just what we know, but how we know it, blending the boundaries between science and philosophy. As we venture further into this idea, it's worth asking, if time is an illusion, what does that mean for our lives, our choices, and our sense of self? Could this theory reshape not only our scientific understanding, but also our very perception of reality? Picture a universe that never truly begins or ends, but instead pulses with an eternal rhythm, like the beating of a cosmic heart. This is the essence of the cyclic universe theory, a captivating idea that suggests our universe is caught in an infinite loop of creation and destruction. Instead of a single, linear timeline stretching from a big bang to an uncertain future, time here becomes a series of repeating cycles, each one a universe in its own right, born from the ashes of the last. But what does this mean for our understanding of time? If the universe is cyclical, is time itself just a loop? At the heart of this theory is the idea that the Big Bang wasn't a singular event, but rather one in an endless sequence. Each cycle begins with a rapid expansion, much like the one we observe today, followed by a period of growth and eventual collapse. This collapse doesn't mark the end, though. It's the prelude to another Big Bang, kickstarting the process all over again. Time in this model isn't a straight arrow pointing forward. It's more like a spiral, endlessly circling back on itself. This raises profound questions about the nature of eternity. If the universe repeats itself endlessly, is there any real beginning or end? Or are these just illusions created by our limited perspective? One of the most intriguing implications of the cyclic universe theory is how it reshapes our sense of time's flow. In a linear universe, time feels like a one-way street. Moments pass, never to return. But in a cyclic universe, every moment, every event might recur infinitely. Imagine the possibility that every choice you've ever made, every life you've ever lived, could repeat in some form across countless cycles. It's a dizzying thought that challenges our deepest assumptions about existence. Could eternity be less about permanence and more about endless repetition? Yet the cyclic universe theory isn't without its challenges. For one, it's incredibly difficult to test. Unlike the Big Bang, which leaves behind observable evidence like the cosmic microwave background, the cycles of a universe before ours would leave little to no trace. This makes the theory more of a philosophical framework than a scientific certainty, at least for now. Still, it offers a fascinating lens through which to view the cosmos, a reminder that our understanding of time and reality is still evolving. So, is time just a loop? The cyclic universe theory suggests it might be, but it also invites us to think bigger. If time isn't a straight line, what does that mean for free will, for destiny, or for the meaning of life itself? These are questions that stretch beyond science, touching the very core of what it means to exist in a universe that might be far stranger than we ever imagined. What if everything we experience, including time itself, is nothing more than a sophisticated simulation? This is the core idea behind the simulation hypothesis, a concept that challenges our understanding of reality at its very foundation. The theory suggests that our universe might be an artificial construct, like a hyper-advanced video game, created by an intelligent civilization far beyond our comprehension. If this is true, then time, the very fabric of our existence, could simply be a programmed feature, a tool designed to give structure to this simulated world. Think of it like this: in a video game, time progresses based on the game's internal clock, not the real world's. A day in the game might pass in minutes for the player outside. Similarly, in a simulated reality, time could be entirely artificial, a mechanism to sequence events and create the illusion of continuity. This raises fascinating questions. Is time linear because it's programmed to be? Could it be paused, rewound, or even altered by the creators of the simulation? The roots of this idea stretch back to philosophy and science. René Descartes once pondered whether reality could be an illusion crafted by a deceptive force. In modern times, thinkers like Nick Bostrom have formalized the simulation argument, suggesting it's statistically probable that we're living in a simulation. On the scientific side, some physicists have explored whether the universe's mathematical nature hints at a programmed reality, but not everyone is convinced. Critics argue that the simulation hypothesis is untestable. There's no way to prove or disprove it. Others point out that even if reality is a simulation, it doesn't necessarily change how we experience time or the world around us. After all, whether time is natural or artificial, it still feels real to us, yet the implications are mind-bending. If time is a programmed feature, our past, present, and future could be non-linear, existing simultaneously in the code of the simulation. Events might not unfold in a straight line, but in a complex web of possibilities manipulated by unseen creators. What does that mean for free will, for the nature of existence itself? While the simulation hypothesis remains speculative, it forces us to rethink our relationship with time and reality. It invites us to consider that the world we know might be far stranger and more malleable than we ever imagined. And whether you find it thrilling or unsettling, it's hard to deny that this theory opens the door to some of the most profound questions we can ask about the nature of our existence. Have you ever noticed how a single moment can stretch endlessly during a crisis, yet years seem to fly by in what feels like the blink of an eye? This phenomenon isn't just a trick of the mind, it's rooted in the way our brains perceive time. Psychological research suggests that our experience of time is far from objective. Instead, it's shaped by a combination of memory, attention, and emotional intensity. Take, for example, the way time seems to accelerate as we grow older. When you're a child, a single summer can feel like an eternity. Yet, as an adult, entire decades can pass in what feels like a heartbeat. One theory explains this by pointing to the way our brains process novelty. When we're young, everything is new, and our minds are constantly encoding fresh experiences into memory. But as we age, life becomes more routine and fewer moments stand out. With fewer mental markers to divide time, it feels like it's slipping by faster. On the other hand, in moments of high stress or danger, time can appear to slow down. Think about those split-second moments during an accident when everything seems to happen in slow motion. This isn't because time itself has changed, it's because our brains are hyper-focused, processing massive amounts of information in a short span. This heightened attention creates the illusion of elongated time, allowing us to react more effectively to the situation at hand. Memory also plays a crucial role in how we perceive time. When we recall a period filled with significant events like a busy vacation or a life-changing year, it feels longer in hindsight. That's because our brains use these memorable moments as anchors, stretching the perceived duration of that time. Conversely, uneventful periods tend to blur together, making time feel shorter when we look back. So, what does this tell us about time itself? Some scientists argue that time, as we know it, might be more of a mental construct than a fixed reality. Our brains create a sense of continuity by stitching together moments of perception, but this doesn't necessarily mean time flows the way we experience it. Could it be that time is simply a way for our minds to make sense of the world around us, rather than an inherent feature of the universe? The answer might just lie at the intersection of psychology, neuroscience, and philosophy, challenging us to rethink everything we thought we knew. What if everything we think we know about time is just the tip of the iceberg? As we peer into the future of physics, philosophy, and technology, the concept of time as we understand it might be on the brink of a radical transformation. Picture this: scientists are already probing the boundaries of space-time, unraveling mysteries that could redefine how we perceive past, present, and future. Quantum mechanics, for instance, has already hinted that time might not be as linear or absolute as we once believed. And with advancements in fields like artificial intelligence and computational physics, we're inching closer to models of the universe where time could be manipulated or even transcended entirely. Imagine a world where humanity gains the ability to alter the flow of time, not just in theory but in practice. Could we one day create devices that allow us to slow down, speed up, or skip through moments? While this might sound like science fiction, breakthroughs in quantum entanglement and space-time manipulation suggest it's not entirely out of reach. And then there's the philosophical side of the equation. If we can manipulate time, what does that mean for free will, destiny, or the very nature of existence? These aren't just abstract questions, they're profound challenges to the foundations of how we see ourselves and our place in the universe. But the future of time isn't just about technological or scientific breakthroughs, it's also about the questions we continue to ask. Every discovery, every theory, every experiment brings us closer to understanding time's true nature, yet each answer seems to raise even more questions. That's the beauty of it. Time is a puzzle that keeps evolving, inviting us to explore, hypothesize, and dream. As we move forward, one thing is certain: our journey to understand time will shape not just the future of science, but the way we experience reality itself. So, what have we learned from these 15 strange theories about time and reality? At their core, they all challenge the very fabric of how we perceive existence. From the idea that time might be a construct of our minds to the possibility that multiple realities coexist simultaneously, each theory invites us to question the nature of our universe. If time is indeed an illusion, it means that the past, present, and future might not be as fixed as we believe. This has profound implications for everything from our understanding of history to the choices we make in our daily lives. Think about it. If time isn't linear, then every moment could exist simultaneously, layered like pages in a book. This might explain why some physicists argue that free will is an illusion, or why others suggest that our reality could be just one of countless parallel universes. These ideas don't just belong to the realm of science fiction. They're grounded in serious scientific inquiry, and they force us to reconsider what it means to be human. The overarching theme here is clear. Our understanding of time and reality is far from complete. These theories remind us that the universe is far stranger and more complex than we often assume. They challenge us to think beyond the limits of our everyday experiences and to embrace the possibility that the truths we hold dear might one day be overturned. As the physicist Carlo Rovelli once said, "Time is ignorance." This simple yet profound statement captures the essence of these theories, that time might not be a fundamental feature of the universe but rather a way for us to make sense of it. It's a humbling thought, isn't it? So, what does this all mean for us? It means that the mysteries of time and reality are still waiting to be explored. Whether you're a scientist, a philosopher, or simply someone who's curious about the nature of existence, there's so much more to discover, and that's where you come in. What do you think about these theories? Do you believe time is an illusion, or do you see it as an unshakable truth? Share your thoughts in the comments below, and let's keep this conversation going. After all, the search for understanding is what makes life so endlessly fascinating.